All right, let's talk trigonometry. You probably spent hours memorizing formulas, right? But what if I told you there's a powerful shortcut hidden in plain sight, built right into the names of the functions themselves? Well, today we're going to unlock it. Have you ever stopped to wonder about this? Why is a sine of 30 degrees the exact same number as the cosine of 60 degrees? Or why sine of 75 degrees is the same as cos of 15 degrees? It feels kind of random, like a weird coincidence we're all just supposed to memorize. But trust me, it's not a coincidence at all. It's a system. The entire secret is hiding in that little two-letter prefix, co. You see it all the time. Cosine, cotangent, cosecant. That little co isn't just filler, it's the key that unlocks this whole thing. And here's the big reveal, that co literally stands for complement. So cosine isn't just some other function, it's the complementary function to sine. Once you get that, everything else just clicks into place. This gives us these three perfect pairs. You've got sine and its complement, cosine. You have tangent and its complement, cotangent. And of course, secant with its complement, cosecant. They're all linked together by this one simple idea. Okay, so that's the what, but what about the why? Why does this even work? Well, to prove it, we don't need some crazy, complicated equation. We just have to go back to where it all started, the simple right triangle. You remember this rule from geometry, right? You've got one 90-degree angle, and since a triangle's angles have to add up to 180, the other two, the acute ones, must add up to 90. They are, by definition, complements. So if we call one angle theta, the other one has to be 90 minus theta. All right, so let's park ourselves at angle theta for a second. We all know the definition of sine. It's the length of the side opposite the angle divided by the hypotenuse. Easy enough. Now let's hop over to the other acute angle, its complement. The definition of cosine for this angle is its adjacent side divided by the hypotenuse. But wait a minute, look closely. The side that's adjacent to this angle is the very same side that was opposite our original angle theta. And that's the whole magic trick right there. The labels opposite and adjacent just depend on which corner of the triangle you're looking from. The actual side of the triangle doesn't change one bit. So the sine of one angle and the cosine of its complement have to be the same value, because they're literally describing the exact same ratio of sides. Now, this beautiful relationship isn't a one-off thing just for sine and cosine. Nope, it works for all three of our cofunction pairs. So let's lay out the complete toolkit of identities that you can now use. And here they are, the whole set. The sine of an angle's complements is the cosine of the angle. The tangent of a complement is the cotangent. The secant of a complement is the cosecant. And you can see it works perfectly in both directions for every pair. It's a completely symmetrical system. Oh, and by the way, this works for radians too. Just swap out 90 degrees for pi over 2. Okay, theory is great, but let's get to the good stuff. How does this actually save you time and headaches? This is where this little trick becomes a real superpower. Let's see how it lets us tear through expressions that look way more complicated than they really are. Take a look at this. At first glance, your brain might start searching for some weird expansion formula to apply. But with our new cofunction knowledge, we can solve this in like 5 seconds. So here's the process. Step 1, you immediately spot that sine of 90 minus x. That's our cofunction identity right there. Step 2, we know that's just a fancy way of writing cos x, so we just swap it. And now, look at our new expression. It's just cos x plus cos x. It doesn't get much simpler than that. And boom, there's the answer, 2 cos xx. We went from a confusing-looking problem to a clean, simple answer in one move. No calculator, no complex formulas. That's the power we're talking about. So why is this such a game changer? Well, for one, it cuts down on what you need to memorize. If you know the sine of 30, you automatically know the cosine of 60. It makes calculations way faster, and it makes simplifying big, ugly proofs so much more manageable. It's just a more intuitive way to think about how all these functions relate. So if there's one thing you walk away with today, let it be this. The co is your clue. It means complement. Cofunctions are just complementary functions, and once you know the code, you can't unsee it. Makes you wonder what other secrets are hiding in plain sight in the language of math.